Hello guys, let's continue the solution of worksheet 7, which is talking about the interval on which the function is increasing or decreasing by using the first derivative test. Here, as you see from the graph, he asks you in this question number 2 to use the graph to estimate the open interval on which the function is increasing or decreasing. Then find the open intervals analytically. What we mean by analytically, we mean algebraically. Here it means I have to use the graph to identify the interval, then find the answer algebraically. By looking at the graph, I have to identify first the critical number. As you see, the critical number occurs at the place or at x where the function has a horizontal tangent, or it has what else? It has a cusp, sharp point, it has relative maximum or relative minimum, absolute by any way. In this case, we have a critical number at x equal what? -1. As we know, the critical number divides the domain of the function. The value at which the function is what? Defined. Here, as you see, we consider the domain all of real number because it is what? Polynomial function. The given function is what? A polynomial function. As the critical number here divide the domain into two intervals. The first interval here, that is the first interval, that is what? The second interval. Open interval here, -infinity and -1. The second interval, -1 and infinity. I named the infinities by its to end, but here it is not end because it is open interval. Okay, as you see on the first interval, the function is what? Increasing. Okay, and on the other interval, the function is what? Decreasing. In this case, we write the function is increasing on which interval? So trivial. -infinity and 1. -1, sorry. Function is decreasing on which interval? -1 and infinity. We can identify from the graph by using this one. Identify first the critical number. You have to know the interval, the open interval on which a function increase or decrease. It has what? Here -infinity, critical number, infinity, or between two critical number. The ends of the interval, or the limit of the interval from two sides. The limit of the interval from two sides is what? Critical number or infinity. Two critical number, one critical number, infinity, and so on. Okay? Not the test value because some of you did this mistake. Now, how to find this one analytically? First step, find the derivative. What is the derivative? Apply the general power rule. Since the function is a bracket raised to power. Okay? So, I'll apply the power, multiply the number in the bracket. It will be here -2 multiply x plus 1. The bracket decrease the power by 1. Multiply the derivative of what inside the bracket, but it is what here 1 can be submitted. Then find the critical number at which here, since our function is polynomial function, I'll find the case at which the derivative is 0. Put the value of the derivative equal 0, -2 multiply x plus 1 equal 0. This is imply the zeros will come from the bracket. X plus 1 equal 0 implies x equal -1. So -1 يبقى critical number x equal -1. But you have to make sure the critical number in our domain. -1 in the domain of the given function, yes, because it's a domain, this function, it's a domain what? The all real number, okay? The critical number must be in the domain, okay? Number 3. I have to draw the number line, which here -infinity and here infinity, which represent what the domain of the function, and the critical number in the domain. In what? The domain. But I have to also, I use the values of the function, the values of x at which the function not defined on the number line, just to identify the interval in which increasing or decreasing. But in this case, I use the critical number because the function defined on all of them. Here, the first interval here, which is what? -infinity, okay, and -1. The second interval is what? -1, infinity, okay? Here, I have to choose test value. The fourth step, choose the test value. Number in each interval, okay? I'll choose here -2, and here I'll choose what? 0, okay? Then replace in the derivative. Replace in what? In the derivative, okay? -2 multiply, it will be 2. Greater than 0. Here the derivative equal positive number, so the function is what? Increasing. Here replace also in the derivative, it will be -2, it means less than 0, it means negative, so function decrease. I use the test value to know the sign of the derivative. If it is positive, the function is increased on the interval on which the derivative is positive. The function decrease on the interval, okay, on which also the derivative is what? Negative, okay? Here, in this case, I will write a function, is what? Increasing on what? Which interval? The smallest value, then -1, okay? -infinity and -1. Function is decreasing on which interval? -1, infinity. I hope you understand well, okay? Clear? Let's solve the next question. This one, question number 3, would you like to solve number 3? I think number 3 and 4, I named this one number 3. Solve by the same way. Identify where are the critical number, okay? Then what is the behavior or the function interval on which, the function increasing on which interval, decrease on which interval. Okay, I'll solve number 3 or number 3, okay, I'll solve it. At the beginning, where are the critical number? Here, as you see here and here, because the derivative of the function equal 0, or the graph has a horizontal tangent, which means the derivative equal 0. Now, as you see here, the critical number divide the domain of the function. Since this function is a polynomial function, its domain is what? All real number, and the critical number contained in this what? In its domain. Here we have to know what is the behavior of function increase from a -infinity to -2, the function is increased. From -2 to 2, the function is what? Decrease. From 2 to infinity, the function increase. Okay, that is from the graph. If here the given function is increasing on which two interval? Here, increase, increase, increase. Here what? Increase, here decrease. Increase on negative infinity and negative 2. And the second open interval, which is what? 2 and infinity. Okay, function f is decrease on what? Negative 2 and 2. That is from the graph. Identify where are the critical number. Then by looking at the graph, you can identify where is the function is increase or where is decrease. Okay, that is from the graph. Sometimes I give you the question to identify the interval from the graph, but sometimes I will not give you the graph, just to give you the rule of the function. So we will use how to use the rule of the function to find the interval. Follow the steps. I think it's so easy now. Here we can rewrite this by 1 over 4 x to power 3. Then apply the rule of differentiation. The derivative equal what? 3 over 4 x to power 2. Just to multiply, power rule, minus 3. Second step, write the derivative equals 0. 3 over 4 x to power 2 minus 3 equal 0. Implies what goes to the other side? 3 over 4 x to power 2 equal 3. Then divide both sides by 3/4 x squared. It will be 4. So x, it will be positive or negative 2 are critical number. Critical, you have to write critical number equal x equal negative 2 and 2. They are included in the domain of the function. Okay, I will take it. Okay. Third step, as usual, open line to show the domain of the function, negative infinity and infinity, because the domain all the real number. Then write the critical number on it from the smallest to the greatest. The fourth step, the test value which included in each interval to know the sign of the derivative. I don't care about the value of the derivative, but I care about its sign. Here I choose which is negative 3. Here I'll choose 0. Okay, it's better for you to choose the values which easy to substitute by it in the derivative. Okay, here I'll take what? 3. If we replace by 3, negative 3, it will be positive 27 over 4. It will be positive. Just use your calculator to substitute. Since the derivative here is what? Positive, increasing. If we substitute by 0, it will be negative 3, it will be negative. Okay, function is what? Decrease. Then add 3 by the same way, it will be what? Positive. So function is what? Increase. Okay, the value of the derivative, use your calculator. Use your calculator. Okay, here f is increasing, or increase is on negative infinity, negative 2. I'm talking about the two ends of the interval, or the two limits of the interval from right or from left, the limit of the interval from right or from left. Here, negative infinity and the critical number. It will be critical number or infinity or negative infinity. Don't take that test value. Okay, and because some of you did like this mistake, here it will be 2 and infinity. Okay, here what? Increase, here increase, and here decrease. Okay, f the function is decrease on what? Negative 2, the open interval negative 2 and 2. Okay, I think it's so easy. By the same way, you can solve number 4. Okay, here how many critical number? Here, here, here. 3 critical number, -1, 0, and 1. Then continue the solution by the same way. Okay, now I'd like to all of these number 9, 10, 11, 12, use the same steps, the same way, 4 steps or 5, 6 steps as we did before. But here I'd like to solve with you number 11 because the others one so easy and you can check the answer from the model answer which I posted already on the LMS. Now here for number Y, because it is different, I'd like to solve it. Okay, now here at the first step I have to rewrite the function to be ready for the derivative as you learned it before, x plus 4 x to power -1. Okay, then now find the derivative. It will be, what is the derivative? 1 minus 4 x to power -2. That is the first step. But I have to simplify the derivative, which is what? 1 minus 4 over x to power 2. Okay? To simplify, I have to do the operation, which is subtraction. It will be, I have to make the two term like. To do the subtraction, the two term must be like. How to make them like? They have the same denominator, x squared. Make both of them have the same denominator, x squared. Then multiply x squared here. And here x squared, it will be x squared minus 4. I'd like to tell you something, maybe I forgot to tell you from the beginning. The domain of this function or real number except x equals 0. Because at x equals 0, the function undefined. All of the values of x which make the function defined. X equals 0 is the function undefined. So, in this case, I find what? Please be careful. What is the domain? Here. Then put second step, put what? The derivative equals 0. It will be derivative here. I have two cases for the derivative. Why? The derivative equal 0 or the derivative does not exist. Here the derivative which is what? X squared minus 4 over x squared. The derivative equals 0 if the numerator equal 0. So x squared minus 4 equals 0 implies what? X equal what? Positive or -2. Does not exist if the denominator equals 0 implies what? X squared equals 0. So x equal what? 0. The critical number in this case are +2 and -2. 0, it is not a critical number because the function is undefined at it. يبقى here critical number are what? X equal -2 and 2. Not critical number. Here f undefined at it. And what? Undefined at it. So I take all of the critical numbers such as that the function defined at it. Okay? Here, in this case, I have two critical numbers. But when we draw, look back, first this one, third step. When we draw this one line, be careful, focus. I write all of the critical number and also the value at which is the function undefined because it is also divide the domain. Okay? يبقى here the domain all of the real number except x equals 0. Okay? Here I will write -2 okay and 2. But don't forget also I have to write the values of x such that the function undefined, which is what here? 0. I write the critical number and the values of x at which the function what? Undefined. Okay, clear this point? Here, this critical number, this one critical number, but at 0, function undefined, I have to put it on the interval, which, or the number which represent the domain, because it is also divide the interval into parts. Here, select the test value here, test value here, test here, and test here. Okay, I choose -3, which is less than -2. Here between this one, I will take -1, and here I will take 1. Here I will take 3. Then replace in the derivative. Replace in the derivative. By using the calculator, it will be here positive. Okay, the derivative here what? Positive. So increase. If you replace by -1 in the derivative, I replace here. I replace here. It will be what? Negative value. Use the calculator to find. But to save the time, I tell you the sign after calculation. Here it is what? Also negative. Here what? Positive. Okay? So in this case, function is increasing. Okay, on which interval? -infinity and -2, increase. Okay, here increase, decrease, here decrease, here increase. And what else? Here 2 and infinity. F is in decreasing on what? Decrease on -2 and 0, and the open interval what? 0 and 2. I hope you understand this one. The critical number must be in the domain of the function. Okay, when we draw the third step, I have to put on the line which represent the domain of the function, okay, the values of the critical number and also the value at which the number, the function undefined. I hope you understand this problem well, okay. For the others question, it's so easy. This one more difficult, that is why I solve it with you. But number 9, 10, 12, so trivial, solve it as we solved it before, and they are homework. Okay, thank you for joining the session. Bye bye.